Hello everyone, my name is Carlos Bezerra. I am a master's degree in software engineering and today I am going to present my paper on an HL7-based middleware for exchanging data and enabling interoperability in healthcare applications. My presentation is organized as follows. I will go through a brief introduction to health information systems. We will then see some basic concepts for HL7 and middleware. The proposed solution, which is a middleware based on the HL7 standard, capable of integrating EHR data through a cloud service that encodes, stores, and synchronizes data between HIS. The results we obtained, and we will wrap up with the conclusion. Health information systems process on a daily basis a large amount of information that assists health organizations in their operational and administrative activities. As determined by the good practices of international bodies, an HIS should provide safety and uniformity mechanisms for EHR, preserving the history and evolution of clinical data, which can be used and shared by other health domains. Currently, the HL7 standard provides a set of specifications that aim to standardize the exchange and transfer the information between HIS. Although the HL7 standard is being debated and applied in the most diverse health sectors, one cannot see the lack of tools and software solutions based on the HL7 standard for exchanging data and service between health applications. This work specifies a middleware based on the HL7 standard, capable of integrating EHR data through a cloud service that encodes, stores, and synchronizes data between HIS. To do so, we have specified a middleware architecture that exemplifies how the proposed solution extracts the EHR data from a legacy system, encodes message in the HL7 standards, store the data in a cloud solution, and synchronize the message with other health applications. Health Level 7 is an international standard that contains a set of standards for the transfer of clinical and administrative data between software applications used by healthcare organizations. This standard is based on the Open System for Intercommunication 7-layer model and specifies a set of flexible standards, guidelines, and methodologies through which various health systems can communicate. These guidelines or data standards are a set of rules that allow information to be shared and processed consistently. In addition, an XML-based markup standard specifies the coding, structure, and semantics of clinical documents. The standard also provides events that trigger messages to interconnected software systems. These events represent the patient care activities that occurs in the health domain, such as inpatient hospitalizations. An HL7 message is formed by one or more segments, which are reusable subparts that contain pertinent information related to this type of message. Each segment consists of one or more data fields, which in turn can be subdivided into data components. Middleware is intermediate layer between distributed application and an operation system, which aims to abstract the heterogeneity of the application, making the distribution characteristics transparent to the user. The main idea is to act as intermediary component between two layers and providing communication between the connected parts. There are types of middleware that can be implemented with the purpose of exchanging and interoperating data, such as transactional, procedural, message-oriented, and object-oriented. The middleware proposed in this work is characterized as message-oriented. In this type of middleware, a client can send and receive messages asynchronously from any other client, connected to a special agent that provides facilities for creating, sending, receiving, and reading messages. The proposed middleware architecture aims to facilitate the configuration of how information is exchanged between various institutions and health agencies. Such information exchange uses a single point of cloud storage that centralizes all the execution necessary for the distribution of the information structured with the HL7 standard. The middleware developed in this work consists of two main components called HCloud Middleware and HCloud Client. H-Cloud Meter refers to the model that is hosted on a cloud computing architecture, while the H-Cloud client refers to a local application that uses the services of the cloud component. HCloud client can connect to different database systems and isolate the technical details of each technology in a component, hiding the details and enabling each new database technology to be dockable without major programming efforts. The main components of the architecture illustrated in Figure 2 are detailed as follows. The HCloud client is responsible for providing the functionality necessary for healthcare facility to build the HL7 message from the information stored in its data schema. For exchanging HL7 standard messages, the HCloud client component connects and synchronizes data with the cloud component. In addition, the HCloud client has other subcomponents that are detailed next. The receive and sender components are responsible for contacting the HCloud meter in case of new messages. The HL7 model component specifies the formats of the message and verify whether they conform to HL7 specifications. The repository component manages the data persistence that is received through the business rules for the HCloud client. For the process of mapping information from the relational data schema to the HL7 standards, the following rules are considered. Every message must 1. Be related to a health event. 2. Follow the message composition layout specified by the HL7 standard. 3. Be constructed as soon as the trigger representing the health event is activated in the database, and 4. Contain information composed of fields from the database tables. The HCloud client has been designed with a mapping functionality for each group of events specified in the HL7 standard. The mapping functionality contains a set of HL7 data requirements. For each selected event, it's possible to choose the table column of the relational data schema of a health application. In addition, it's possible to configure triggers that transmit encoded messages from the client service to the cloud. Data synchronization with other institutions is performed as follows. The messages available in the HCloud meter are displayed in the HCloud client graphical user interface, and for interoperability to occur, the user must activate the functionality that will request the HCloud meter to transmit messages. You can see a codified message in HL7 format. To evaluate the interoperability efficiency and the data integration service proposed here, we have used a real scenario composed of three health institutions located in the northern region of Brazil. He called as Hospital A, B, and C. Hospital A uses Microsoft SQL Server as database management system technology. Hospital B uses Oracle, and Hospital C uses PostgreSQL. In this scenario, 10 loads were submitted containing 10,000 records referring to patients' admissions. As a result of this evaluation, 1. HL7 measures were codified correctly. 2. Information exchanged. 3. Data decodified, and finally 4. The information integrated. In addition, we calculated the approximate time of each hospital in the activities of encoding, sending, receiving, decoding, and synchronization. As shown in Table 1, the middleware spent an average of 255 milliseconds to encode HL7 messages and 2,868 milliseconds to send messages to the cloud services. Receiving messages at each hospital has spent an average of 5,670 milliseconds, decoding messages 510 milliseconds, and synchronization with the database 5,595 milliseconds. This paper presents a middleware based on the HL7 standard capable of interoperating electronic health record data through a cloud service that encodes, persists, integrates, and synchronizes EHR data between health information systems. The main contributions are 1. The specification of an architecture that shows the software components and their relationships. 2. The implementation of a tool and the components that map and encode information from a relational data schema into HL7 messages. And 3. A demonstration of how data interoperability is performed using the developed tool through a real hospital scenario. As future work, the middleware's performance evaluation to process large data volume is considered.